Hello, my name is Miguel Loureiro and I work for TSK, and I will briefly explain a clean hydrogen model developed to take advantage of the gases of refuel. Specifically, the model was designed for the output gases from the salt slag recycling process. First, gas composition and concentration was measured by INATEC and also by external laboratories to confirm accuracy and reliability. Volume flows were also measured by gasometries. So, clean hydrogen model was designed from this input data, and it should be taken into account that with a different gas composition, the process might be modified and the model wouldn't be valid. The clean hydrogen model was designed and simulated in Aspen HYSYS. And it starts with a compression in 2 steps, which increases gas temperature. This thermal production, up to 100 and 400 degrees, could also be exploited. Then, gases are purified to increase the percentage of hydrogen. Values of purity, recovery, and inlet conditions from a commercial PSA were considered for this step. Pressure swing absorption is a technique used to separate different gases from a mixture at pressure through selective adsorbent materials, which are used as trapping materials. Due to the slag recycling process is a batch process, storage is needed to control the discharge flow rate. In this case, a tank at 100 bar is considered the most suitable option. Finally, hydrogen could be used in process in blending with natural gas or in a fuel cell for electricity production. Here, the 4 stages modeled in HYSYS are shown: compression, purification, storage, and final use. From left, gases from refuel, to right, output hydrogen gas. Going more deeply to some numbers, with the specific mass flow from refuel of 160 kg/hour and the considerations taken into account, approximately 120 kg/hour of hydrogen could be produced, equivalent to a production in a fuel cell of more than 2 megawatts. In this scheme, you can see the evolution of pressure during the process. Here, the compression step before the purification, and here another compression to achieve the 100 bar needed for storage. Later, the pressure is decreased until its final use. This evolution in pressure involves an evolution in temperature. You could see values after compression up to 400 degrees. On the other hand, storage and final use are considered at ambient temperature of 25 degrees. The model developed has only one input to the users: gas mass flow, and it calculates to the user the following outputs: production of hydrogen or electricity, production of heat, electric consumption, efficiency, and equipment and utilities costs. These costs were obtained from HYSYS, literature, and commercial data. Finally, the results obtained in HYSYS for different inlet mass flows were implemented in Python to ensure compatibility with the TRINEFLEX platform. This was all for the clean hydrogen model. I hope that it helped you to support decision making related to plant optimization. Thank you very much for your attention.